Okay, so in my first video of laws of motion series, I have discussed about Newton's first law, second law, and third law. Actually, Newton's first law. So now I'm going to discuss about Newton's second law. Actually, Newton's second law is the real law. This is the real law. So, according to Newton's second law, the external force applied is directly proportional to a rate of change of momentum. External force applied is directly proportional to rate of change of momentum. So here we have to understand what is momentum. So momentum is nothing but product of mass and velocity of a body. Momentum is product of mass and velocity of a body. Its unit in SI or MK system is kg into meter per second, whereas in CGS system it will be gram centimeter per second. And dimensional formula of momentum is for kg it is mass m, for meter it is length m1, l1, and second inverse that is time inverse. This is the dimensional formula of momentum. And momentum is a vector quantity. In notation we can write p is equal to mass into velocity. So momentum is a vector quantity. P is a vector quantity, mass is a scalar quantity, but p equal to m into v is a velocity, is a vector quantity. This is velocity, m is mass, and p is momentum. Basically, I am talking about linear momentum. In my future slide, I'll be discussing about angular momentum. These are very basics, and you should understand what is momentum. I hope everybody clear. But according to Newton's second law, external force applied is directly proportional to rate of change of momentum. So when momentum is changing with respect to time, then we can get force. So one can say momentum is force is time derivative of momentum. So now let me erase it out. So Newton's second law is real law, because from Newton's second law you can talk about Newton's first law and also Newton's third law. And in my previous class, I have discussed about Newton's first law, where I am talking little bit about centripetal force. So I'll be coming back to centripetal force at the end of the slide again, once again. But now we got that force is a vector quantity is proportional to rate of change of momentum dp by dt. So force is time rate of change of momentum. So if you are getting a graph in any question where momentum is along y axis and time is along x axis, whatever the figure, I mean shape of the graph, but if you want to calculate the slope, so slope of this graph, slope will be change in momentum by change in time. Here I am using this delta for change, or simply one can write small change in momentum with respect to small change in time, which is force. Remember, these kind of questions are being asked in the entrance exam. So if there is a change in momentum with respect to change in time, when we are talking about a graph having y-axis represented by momentum and x-axis represented by time, then the slope of this graph will give you force. Remember this. So slope of momentum time graph will give force. Slope of momentum time graph will give force. If you want, you can pause my video and you can write this. But to save your time and internet bill, I have to make it faster. Hope everybody can understand what I'm saying. So force is rate of change of momentum. So now force is equal to some constant into dp by dt. So Now, now let us get back to this thing. So force is equal to k into dp by dt, where k is proportionality constant. K is proportionality constant, and let us consider the value of k to be 1 for simplification. So if I'm taking k equal to 1, my f will be dp upon dt. Since momentum is a vector quantity, that's why I'm writing like this. So basically I have got f equal to dp by dt. So time rate of change of momentum or time derivative of momentum, or if I differentiate momentum with respect to time, then I'll get force. So let me start writing from here. So, external force applied is directly proportional to rate of change of momentum, and taking proportionality constant to be 1, then we can write F is equal to dp upon dt, and we can write F is equal to d by dt mass into velocity. So, momentum is mass into velocity. So, momentum is mass into velocity. So, what we can do? We can consider mass to be constant, then velocity to be variable, then again mass to be variable, velocity to be constant. So we'll apply the property of derivative. Derivative of two different function u into v, when they are multiplied, will be derivative of first function with respect to time into second function plus first function into derivative of second function with respect to time. We should do like this. So f is equal to d by dt mv. So what we can do, we can write f is equal to dm by dt into v, means derivative of first function into second function plus first function into derivative of second function, first function into derivative of second function. So f is equal to this much. So from here we can consider two cases. One is when mass is constant. From the formula of derivative, derivative of constant quantity is 0. So when mass is constant, my value dm by dt will be 0 for this case when mass is constant. So since dm by dt is 0, because mass is constant, derivative of constant quantity is 0, I am writing it here. D by dt of any constant quantity will be 0. So here dm by dt is 0 when we are considering mass to be constant, m to be constant. So what I'll get, so this term will become 0. So only this term will be there. F is equal to m dv upon dt. So dv upon dt, time rate of change of velocity is acceleration. So that is mass into acceleration. So we've got F equal to mass into acceleration. This is one expression. Similarly, if I consider in my second case velocity to be constant. So this is the case when rocket propel to outer surface from the earth, from the ground or above the ground when it is moving. So in case of rocket, we are taking velocity to be constant. So dv by dt will be 0 now, because derivative of constant quantity is 0. So this term will be there only. So f is equal to dm by dt into v. This is upward thrust. This f is upward thrust, and this theory will be used in rocket propulsion, where we are taking mass to be variable and velocity to be constant. That is the theory of rocket propulsion. So hope everybody are clear up to this, and you can pause the video and take the notes. Look, taking notes is not important. You can refer any book. For me, the most important book is, if I can suggest, one of the finest book, I mean all time best, that is let me go, that is of course Resnick, Holiday and Walker. That is the best book you can follow. Resnick Holiday Walker. So what you do, just watch my video and please read Resnick Holiday Walker, else you can read NCRT book and start solving problems and ask me your doubt in the comment section so that I can make more video. And if you want to ask me doubt on the WhatsApp, my number is 9090700977. So this video is dedicated to the students who are really interested to learn physics and understand physics. And this is the number you can ask your doubt. If you're asking any question in terms of doubt, it will give me two profit. One is I'll be challenged by you to understand physics by solving the problem. Second is I can make more videos on that problem. So thank you for watching my video and please provide your necessary comment in my comment section so that I can make more video for the benefit of the students. Okay, so now you have understood that if I take mass to be constant, I will get Newton's second law, that is F equal to ma. If I'm taking velocity to be constant, I'm getting F equal to dm by dt into v, because dv by dt will be 0. So this is rocket propulsion. So now quickly I'm moving to Newton's second law, and let me discuss little bit about rocket propulsion too. So if you want, I can summarize this once again for your better understanding. Let me make a chart so that you can understand once again. So what we generally do in Newton's second law of motion. Basically force force is equal to rate of change of momentum dp by dt. So what I'm doing it, I'm making it d by dt of mass into velocity, but I can make it two way, that is dm by dt into velocity plus m into dp by dt. So it can be differentiated into two things. When I'm taking mass to be constant, then my dm by dt will be 0. So dm by dt will be 0. This term will be 0. So I'll be getting F equal to m dv by dt. dv by dt is a, so ma. So a is acceleration, m is mass, f is force. So from here we can write the unit of SI or MK system unit of force, that is for mass it is kg, for acceleration it is meter per second square. So basically 1 kg into meter per second square is 1 Newton. So 1 Newton can be defined as 1 Newton is the force that can cause an acceleration of 1 meter per second square in a block or in a body of mass 1 kg. अगर हम लोग एक 1 kg ब्लॉक को 1 मीटर सेकेंड स्क्वायर एक्सीलरेशन देने की कोशिश करेंगे तो हमें 1 न्यूटन फोर्स देना पड़ेगा, right? So this suggests from this law. And what is CGS system unit? CGS system unit of force is gram into centimeter per second square, because for mass it is gram, for acceleration it is centimeter per second square, and 1 gram into centimeter per second square is nothing but 1 dyne. So 1 dyne is the unit of force in CGS system, whereas 1 Newton is the unit of force in MKS or SI system. So 1 dyne is the amount of force that can cause an acceleration of 1 centimeter per second square in a body of mass 1 gram. So 1 dyne is the amount of force which can cause an acceleration of 1 centimeter per second square in 1 gram. So we can always find the relation between 1 Newton and 1 dyne. 1 Newton is nothing but 1 kg into meter per second square. So 1 kg will become 1000 gram into 1 meter will be 100 centimeter divided by second square. You know, in SI system the time unit is second, in CGS system the time unit is second. So now how many zero? 1, 2, 3, 4, 5. So it will become 10 to the power 5 gram centimeter per second square, that is nothing but 10 to the power 5 dyne. So 1 Newton equal to 10 to the power 5 dyne. 1 Newton equal to 10 to the power 5 dyne. In my unit dimension video, you can check how I have used dimensional analysis to find the relationship between 1 Newton and 1 dyne. Now Next one is rocket propulsion. So what is happening in rocket propulsion actually? In rocket propulsion, rocket is having many chambers. So its mass is not constant because when the rocket is starting, the fuel from this tank will be, after moving some high position, the fuel from this tank will be gone and that tank will be fallen. So slowly again second tank will be fallen. So slowly you can notice that the rocket is losing its mass. So you can say the mass is not constant with respect to time, but velocity is constant. So since velocity is constant for rocket, so derivative of constant quantity is zero. So this term will become zero, dv by dt will be zero. So rocket propulsion, the upward thrust will be dm by dt into v. This is the upward thrust in rocket propulsion. So this is all about Newton's second law. Let me finish Newton's third law in this slide itself. Please pardon me if I'm making this slide little bit longer, but it is for your better understanding. Newton's third law and conservation of linear momentum. Because after this slide or after this lecture, I'll be directly starting how to solve problems using free body diagram, lift problem, pulley problem. So allow me some more time and to listen this lecture so that I can able to finish Newton's third law itself in this video. And thanks a lot for your patience. Thanks a lot to all the viewers who are listening to this video. So now I am talking about Newton's third law. According to Newton's third law, to every action there is an equal and opposite reaction. To every action there is an equal and opposite reaction. So Newton's third law and first law can be derived from Newton's second law. So Newton's second law is the real law. So thank you. In my next slide, I'll be discussing about conservation of linear momentum and some pulley problem. So thank you for your patience.